All right, let's get started here with pre-calculus. Start from the very beginning. Chapter 1, Section 1, rectangular coordinates. And the first thing we're going to look at here is the Cartesian plane, named after our good friend René Descartes. What we're looking at here, just to review, the x-axis going side to side, y-axis going vertically up and down. They come together here at the origin. And remember, our quadrants go 1, 2, 3, and 4 for our different quadrants. All right, so another way of looking at this is that the x value is the distance from the y-axis, the directed distance, and the y value is the distance from the x-axis, how far away they are. So put those together. X comma y gives us a point somewhere on the Cartesian coordinate plane. All right, so moving right along, let's plot some. So we got a couple points here. -1, comma 2, we're going to go left 1 and up 2. There's point 1. 3, comma 4, we're going to go right 3 and up 4. And while I'm at it, let me go ahead and label this the x and y-axis. 0, 0. Let's go with a different color so we can see it. Right there in the middle, 0, 0. 3, comma 0 would be down here on the x-axis, and -2, left 2, -3, down 3 would be right down here. All right, so you're up now in your textbook, exercise 7. Go ahead and give that a shot. Go ahead and pause the video, try that problem, and get an answer. Check your answer in the back of the book. When you're ready to go, play the video and get things going again. I'll be ready to go when you're done with that problem. All right, so I'm assuming you're done with problem 1. We're moving on to example 2 and looking at sketching a scatter plot. So we've got some data here. The year and then the number of subscribers in millions for that year, and we want to sketch a scatter plot of that data. So let's go ahead and do that here. Start by just graphing, really just graphing quadrant 1 since all the values are positive. All right, and so we want to talk about what's the input and what's the output. The input is the year. That's what we say, okay, in 96, what happened? So that's going to be on our x-axis. So we're going to have t on our x-axis and n on our y-axis. So labeling our axes, very important, first thing we want to do. All right, now let's think about how we want to count our years. All right, so we can call them out as 94, 95, 96, 97, that sort of thing. Probably doesn't make sense to jump, because we know the origin here is 0, to jump from 0 to 1994. So instead, we should call these year 1, year 2, year 3, etc. So if we did that, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think there's one hiding behind the smart ink thing that I can't get rid of. Put you up there for a second. 13 and 14. So 14 tick marks to go on here. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, and 14. All right. And I just made the mistake of deciding to draw my inputs on the y-axis. So I apologize for that. Let's try that one more time. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14 going out. Okay? Sometimes it's helpful just to label 6, 7, 8, 9, 10. Maybe every 10th there, just so it doesn't get crammed in with your numbers, but we're clearly indicating that we're counting by equal amounts, right? So that's important with the tick marks, equal amount. All right, for the subscribers N, on this one, might make more sense to count by maybe 20s, something like that, right? As we go up. And so that would take us all the way up. We would need about 12, 13 of them to get all the way up to 255. So let's do that, counting by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. That's bigger than everything. So we'll label these 20. I'm going to go every other one here. 60, 100, 120, 140, 160, 180, 200, 220, 240, 260. All right, so scatter plot. We're just going to put the information down. We are not going to connect the dots here. So 1 and 24, right about in here. 2 and 33, so that's not much higher. Tough to do this with the smartboard to be exact. 3 and 44 would be a little bit higher here. 4 and 53, a little bit higher. Okay, so I'm not going to put all of them in, but that's how you would do it. We've done the first 4 as we take off there. One thing I do want to point out here that will come up with a couple problems is that if you wanted to start, since this is 0, 0 down here, and you wanted to count by 5s, but maybe your value started at 50 and then 55 and then 60 and so on, and you didn't care about 0 through 50, right? All this information we don't really care about. We just want to start at 50. What we're going to do is give us a little bit of a squiggle down here to indicate we're skipping some values, and then we're going to say, okay, 50, 55, 60, and so on. All right, so now that you've got that, go ahead and try exercise 25 from your textbook. All right, so if you've got that one done, come on back. We're going to talk about the Pythagorean theorem. So 3 sides of a right triangle can be related by the Pythagorean theorem. A squared plus b squared equals c squared. So some common triples, 3, 4, and 5. Remember, 3 squared plus 4 squared, which is 9 and 16, is 5 squared, or 25. Okay? So a couple other common triples that are out there, 5, 12, 13. See if you can find some other Pythagorean triples. All right, and using that Pythagorean theorem, we're going to use this a ton in this course, either calling it the Pythagorean theorem or the distance formula. Okay? The distance formula is the same as the Pythagorean theorem. So let's take a look at that now. Let's say we have a couple points here on our coordinate plane, and let's say that they're, let's get some good numbers here. How about 8, 2, and I'm going to make this one up here 3. Let's make it so the numbers work out evenly. 4, 5. All right, so if we have these, how far apart are these 2 dots? Well, one thing you could do is create a right triangle between them. And what we're going to say is, how far have we moved sideways? From 4 to 8 is 4. How far have we moved up and down? From 2 to 5, we've gone up 3. All right, and so right away we know that the distance is going to be 5. That's the distance formula. Okay, and it's also expressed right here in terms of the points. All right, so what this is saying is the distance from the x value of one point to the x value of the other, the distance from the y value of one to the y value of the other. All right, and then we're plugging it into the Pythagorean theorem. This is the same as saying a squared, here's your squared, plus b squared, here's your squared, equals c squared. But if we just want c all by itself, we're going to take the square root. Okay, so if you need that down, let me erase this so you've got it. Remember, at any point, if you need to, if I'm going too fast, go ahead and pause the video, jump back, see what you need to. Okay, but the distance formula, Pythagorean theorem, very important to have those down. We're going to use them quite a bit. Okay, so, all right, so let's do an example problem on this one, the distance from -2, 1, and 3, 4. So distance formula, let's plug it in. We've got a couple of x values here, -2 minus 3 squared plus the difference in the y values. 1 minus 4 squared. So that's negative 5 squared plus negative 3 squared. And so we've got 25 plus 9. And the distance between those 2 points is going to be the square root of 34. See if you can do it on your own with problem 31. All right, so let's go to example 4. How would we verify a right triangle? All right, so same thing. Distance formula. So we want to say how far are all the points from each other. So on this one, what's the distance between, let's start with these 2 points here. How far apart are they? Well, let's use the distance formula. Difference in the x's, 2 minus 4, plus the difference in the y's, 1 minus 0, squared. All right, so we've got negative 2 squared. Let me just jump right to these. So this is going to be negative 2 squared is 4 plus 1, which is the square root of 5. Okay, so the difference between these two is the square root of 5. We've got that. All right, so you can see that right here. If we were to do that 2 more times, we've got these 2 values here. All right, so we know the 2 distances for D1 and D3 as well. Let's go ahead and plug that all into the Pythagorean theorem. So here we go. A squared plus B squared equals C squared. Let's see if it works out. A squared is the square root of 5 squared plus root 45 squared. Does that equal square root of 50 squared? Well, what happens with square roots and squares? They cancel each other right out. So we just got 5 and 45. Does that equal 50? Absolutely it does. So this is a right triangle. That's how we would prove it using the Pythagorean theorem. So you're up now. Problem 43 is yours to try. All right, midpoint formula. Instead of finding distances, now we're finding halfway points. So there's your formula. Midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So if we've got 2 points sitting out there, there's an x value and a y value, x1 and y1. And then this point has a x value, call it x2, and a y value, y2. Our job is to figure out that halfway point. And so it's just averages. We're going to average the x values, which is what we're saying here, and then we're going to average the y values to find the coordinates of our new middle point. So let's give this a shot. What's the midpoint of negative 5, negative 3, and 9, comma 3? Start with the x's. Find the average of the x's. Negative 5 plus 9 divided by 2. That's 4 over 2. And so the answer there is 2. What's halfway between negative 3 and 3? Well, the answer there is 0. So we figured out the average of the x's. We figured out the average of the y's. 2 comma 0 is our answer. So 47C, just 47C, see if you can find the midpoint there. All right, a couple word problems to try here, and we'll always try to look at a couple word problems. They do show up quite a bit on tests, things like that. So quarterback throws a pass from the 28-yard line, 40 yards from the sideline. It's caught by a receiver on the 5-yard line, 20 yards from that same sideline. And there's a picture in the book, but I thought we'd draw it ourselves here. So here's our football field, right? And so if you're on the 28-yard line, we'll call this the 28-yard line here, and we are 40 yards from the sideline, we would be right here. And then it's caught by a wide receiver on the 5-yard line, and that receiver is 20 yards from the same sideline. He's right here. So all of a sudden we have a couple of points. This one up here, we can call that 40, comma 28. And this one down here, we can call 20, comma 5. Those are our 2 points. All right, so how long is the pass? That sounds like the distance of the pass. So we're looking for a distance formula here. So let's go ahead and set it up. Difference of the x's, 40 minus 20, plus the difference of the y's, 28 minus 5. And you'll notice it really doesn't matter which numbers I subtract here because I'm going to square them. So even if I said 5 minus 28, if I were to flip these two numbers here, it really wouldn't matter because we're going to square it, take away the negative sign. So let's see what we got here. 40 minus 20 is 20 squared, and if we were to square that, we end up with 400 plus 28 minus 5 is 23, and 23 squared, oh, can I do it in my head? I don't think so. Let me go check what it says in the book. 529 is what we've got. That's a total of 929. Take the square root of that, and you get just about 30 yards. Okay? All right, so you're up on this one, problem 57. All right, second to the last one here, there's 8 examples. Number 7, we have sales of 5.1 billion in 2005, 5.4 billion in 2007. Without knowing any additional information, what would you estimate the 2006 sales to have been? Another way of saying that is, what would you estimate the halfway point sales between 2005 and 2007, right? In year 1, we had 5.1 billion. Notice how I turned 2005 into year 1. In year 3, we had 5.4 billion. Those are 2 points. We can find the halfway point, right? 1 plus 3 over 2. That's 4 over 2. That's 2. That makes sense. Year 2, we're trying to find the value. 5.1 plus 5.4 over 2. We get a value of 10.5. And so we're going to end up with 5.25. So we would estimate, all things equal, to have sold $5.25 billion worth of books, sales altogether at Barnes & Noble in 2006, the second year. See if you can do that type of thinking on your own in problem 59. All right, last one, translating points. All right, so the triangle in figure 1.12 has these vertices, so we're starting with this guy here. Shift the triangle 3 units to the right and 2 units upward to find the vertices of the shifted triangle. All right, so you can do it by drawing. I'm going to do it algebraically. All of our x's are going to be shifted 3 units to the right, so that means add 3 to them. And the y's are up 2 units, so that means add 2 to them. So our new coordinates here are going to be 1 plus 3 is 4. We're going to shift up by 2 and end up at negative 2. New coordinates here are 2. We're going to add 3 to get 5. 3, we're going to add 2 and get 5 as well. And then last point here, let's add 3 to this. We'll get 2 and add 2 to our y value and get 4. So those are our 3 new points. One for you to try is on 61, and that's it. You're all done with that. Any questions? Be sure to ask me in class when you see me next. Good luck.